Alright, welcome to part 3 of Projectile Motion 2. Here's our fifth and final question. It says, a ball is shot into the air with an initial speed of 90 meters per second at an angle of 37 degrees. What is the object speed at the highest point in its trajectory? So, when we're going through that, let's picture this again. We've got a ball. I also like to draw pictures quite a bit. That really helps me out. Here's our initial velocity. It is 90 meters per second. And of course, this angle is probably a little greater than 37, but I'm just going to mark it as 37 degrees. So there we've got that ball being launched at this angle. And we know it's going to come up, come back down, land over here. Now, at the highest point in its trajectory, what is its speed? Well, remember at this point there's going to be no vertical velocity and everything is going to be horizontal velocity. So your speed will be equal to your horizontal velocity. Speed at this point equals v naught x, okay, your horizontal velocity. Well, remember that that velocity is constant, so if we know that velocity at any point along the path, we know it everywhere along the path. So if we come back to the original position, if we know the horizontal velocity at this point, we know what it is up here at this point too. So if we know it down here, we know it up here. So how do we find horizontal velocity? We'll go back to our equation for horizontal velocity. Remember, it's equal to the initial velocity times the cosine of the angle. Cosine, because it is adjacent to the angle. So let's plug in our number for initial velocity, 90 meters per second, times the cosine of the angle, which is 37 degrees. Okay, so what is that cosine of 37 degrees? Well, the cosine of 37 degrees is 4/5. So if we come back here, that would be 90 times 4/5. So that is 360 over 5. All right, and so that gives us a speed of 72 meters per second. Now finally, we're getting to our last part of this. Yay, finally, who knew? Okay, a ball is shot into the air with an initial speed of 90 meters per second at an angle of 37 degrees. Part B says, what is the object speed just before it strikes the ground? All right, so we know that that horizontal velocity, let's come back to it, is going to be 72 meters per second. Now, we could go find that the velocity in the vertical direction using the sine of the angle, and doing that, we figure out that, and this was 90, the initial velocity is 90, it's 9 times 37, gives us 54 meters per second. Okay, and that is what it would be here. So we know that this is 72 meters per second, and then this is 54 meters per second, and I didn't draw it to scale here. And then this being 90 meters per second. Okay, and then we could come back and know that using Pythagorean's theorem that 54 squared plus 72 squared, take the square root of those two things, gives us 90 meters per second. Well, this problem's actually easier than that. So we don't really have to worry about really doing any math here. What we need to realize is that the speeds and the velocities at this point at the beginning are the same as this point at the end. So if we've got a speed or a velocity of 90 meters per second here, we're going to have an identical speed here at 90 meters per second. So that is our answer, 90 meters per second. The horizontal and the vertical will also be identical. So this would still be 72 meters per second, and this would be 54 meters per second. And then likewise, this would still be 72 meters per second, and this would be 54 meters per second. Sorry about some of the straight lines. My computer's making a few of them, but there's your answer. Your answer would just be simply 90 meters per second. It's going to end at the same speed that it starts with.